Let's start. Good afternoon, everyone, and thank you for attending this session on elevating GeoServer to the cloud, production-ready features for optimal performance. Over the next 20 minutes, I'll walk you through how GeoServer Cloud delivers scalability, security, and efficiency to meet the growing needs of organizations worldwide. Let's start with an overview of what we'll cover today. First, I will introduce GeoServer Cloud and its role on transforming geospatial data management. Then we'll dive into an overview of what GeoServer Cloud brings to the table, building on the powerful foundation of GeoServer itself. And finally, I will share some case studies that demonstrate how organizations are leveraging GeoServer Cloud to solve real-world challenges and achieve remarkable results. To truly appreciate GeoServer Cloud, let's start with GeoServer itself. GeoServer is the leading open-source geospatial application server. It enables organizations to publish maps and data in open standards like WMS, WFS, WMTS, etc. And over the last 20 years, GeoServer has matured. Haven't we all? My name is Gabriel Roldan, and I wrote the first GeoServer WMS implementation 20 years ago, when it was just an emerging WFS standards compliant application server. Over the years, GeoServer has grown organically to become a trusted tool for geospatial professionals. GeoServer excels in many aspects. Its design and architecture enables high modularity and extensibility. Being standards compliant positions it as a safe alternative to proprietary solutions. It has a very active users and developers community and focuses on quality while at the same time being performance-oriented. But as organizations scale, GeoServer's traditional deployment model can hit limits. Managing thousands of layers, scaling for high demand, configuring secure multi-tenant environments often require significant effort. That's where GeoServer Cloud comes in. It is a microservices-based distribution designed for the cloud. With the dynamic scaling, advanced security, and simplified operations, it transforms GeoServer into a modern, cloud-native app platform. GeoServer Cloud's born 4 years ago, and at this time it's being deployed on battle-proven on all major cloud providers, as well as on in-house or on-premise infrastructures. It's also being used on several domains that require scalability, high availability, resilience, and real-time updates. We currently have deployments for customers on telecommunications, emergency response systems, reinsurance companies, sustainable energy, police operations, environmental protection, and cyber protection. So let's continue with an overview of with a high-level overview of how GeoServer Cloud enables these enterprise demands. So GeoServer Cloud builds on the strengths of GeoServer. It retains all the powerful features of GeoServer and is part of the GeoServer ecosystem alongside the other distributions like the official Docker image, for example, and other GeoServer projects in the GeoServer ecosystem. It is the cloud-native distribution of GeoServer. Let's go to the next one. So, GeoServer Cloud takes advantage of the amazing GeoServer modularity to split its capabilities into smaller and single-purpose applications. Whereas the traditional GeoServer packaging results in a monolithic application providing many services, GeoServer Cloud cherry picks what to include on each application to serve, for example, only features or maps or tiles. Even having the dedicated applications for the REST API and the web user interface separately. Then it has to enhance them with modern capabilities. So we are using a Spring Boot and a Spring Cloud that provides a more flexible plugin mechanism that allows us to decide what to include in the application context, depending on not only on what's available in the class path, but also on externalized configuration. It adds production-ready features like metrics, health checks, and monitoring tools that are crucial for distributed applications to be properly monitored and managed. It adds dynamic load balancing, so opposed to a static cluster of GeoServer instances where you need a load balancer in front with pre-configured targets for each of the instances. In this case, you can scale out to a number of instances, scale in, and the load balancer is gonna know dynamically where to direct the incoming requests. It also adds service discovery so that whenever new pods, as they are called in Kubernetes language, are starting up and down, they will register to the discovery service. And then, for example, the application gateway, that it's the entry point for all the distributed services, is going to know where they are located, or where they're alive, or whether they are ready to be consumed. And finally, distributed events is the other building block of a distributed application. So whenever you have a configuration change, or create a layer, create a workspace, or modify a style, whatever, a distributed event will notify all the pods in the cluster for real-time updates of the configuration. There is no more need to reload the configuration and waiting for minutes for all the pods to react. Finally, GeoServer Cloud ships these applications as a cohesive distributed application. that works as a single unit, but allows you to scale and to dimension each service based on their own performance characteristics or needs. For example, WFS, the Web Feature Service, works with vectorial data, allows you to query vectorial data sets from a data source and serve them in a streamlined fashion. That makes it I/O bound more than CPU or memory bound. So you probably will have the WFS service configured to consume just very little memory and make sure it has enough bandwidth to cope with the required demand. On the contrary, the WMS that creates maps, and it may require more memory and more CPU resources, but maybe not that many, not that much I/O, but obviously depending on the case. Finally, GeoServer Cloud has developed an improved catalog backend. In GeoServer, the catalog is where you store all the layers, style, data stores, etc. The configuration, traditionally that's done in a file system called the data directory. And when you need to scale to a large number of layers, that results in having thousands and thousands of small XML files to be read, especially at a startup. So with GeoServer Cloud, we developed a Postgres-based catalog backend that will store all that configuration in the database, allowing for instantaneous startup. I don't know, we have instances that go on for over an hour to start until they are ready to serve to 7 seconds, something like that. Let's go back for a second. So in essence, we build we build on the foundations of the great things that GeoServer provides, and add support for dynamic scaling, seamless cloud and hybrid integration, and deployment flexibility. Something that any DevOps is going to be very grateful for. So let's move to some case studies on how these capabilities have been implemented in. So let's start with that. Case study one, it's a scalability example for a large telecommunications company. It faced a massive scalability challenge. Their analysts needed to dynamically generate over 500,000 layers for scenario planning, such as optimizing network expansion, assessing environment impact, or evaluating infrastructure resilience. Using traditional GeoServer deployments, this level of dynamic layer generation wasn't feasible due to XML category bottlenecks, limitations on PostGIS rasters. GeoServer Cloud solved this by replacing the XML catalog by the Postgres backend that we mentioned before, and migrating data storage to cloud-optimized GeoTIFF on S3. The result is that they can now generate layers in real time, enabling faster data-driven decisions while reducing infrastructure costs. This level of scalability is just not possible or is now possible because of GeoServer Cloud's cloud-native design. Another example highlights GeoServer Cloud's advanced security capabilities. So a customer needed to securely share geospatial data with external collaborators while maintaining strict internal access controls. So they had separate GeoServer deployments for internal operations and external collaborators, but managing permissions and security was complex and error-prone. With GeoServer Cloud, they implemented GeoServer ACL, which is GeoServer Access Control Lists, for granular role-based access control. Internal users had unrestricted access, while external collaborators were limited to specific data sets and geographic regions. They also integrated OpenID Connect for seamless and secure authentication. And this setup enabled them to confidently share data without compromising security, fostering collaboration. And the final case study, it's for a major reinsurance company, demonstrates how GeoServer Cloud simplifies deployment and operations. They previously managed dozens, like over 60 vanilla GeoServer instances in a passive cluster setup. These instances had long startup times, sometimes over an hour, and required like custom scripts for configuration updates, which had to be carefully planned. And then by migrating to GeoServer Cloud, they transitioned to a Kubernetes-based deployment with dynamic scaling. But now start up in seconds. Configurations updates happen instantly without downtime. And this not only streamlined their operations, but also allowed them to respond quickly to changing workloads, significantly boosting efficiency. We're about to finish, so some key takeaways will be that GeoServer Cloud isn't just a tool, it's transforming the way we provision geospatial services in the cloud. With its scalability, security, and adaptability, it's helping organizations deliver better services to the users while reducing costs and complexity. It's actually already replacing a number of a very well-known major proprietary application server that we all know. Proving that open source can meet and exceed the demands of enterprise needs. Well, it was great. Thanks for your attention. If you have any questions, please